Now let's move to the last part in question 23 or part 23. So in here we have these two questions, question 5 and question 6, similar questions. So in here the question is saying show that the rectangle of a maximum area. Okay, so the rectangle will have maximum area for a given parameter, which means in here if the parameter is constant, okay, is always a square. So show that the rectangle of the maximum area. So if we have the maximum area for a given parameter, okay, which means it's constant, it will be always a square. So we need to show that. We need to show that x and y in the rectangle, okay, it will be in here for x and y, they will be equal. So let's suppose that we have a rectangle. Okay, that's it. This is x and this is y, also x, also y. So let's see how we can solve this question. Here they have mentioned two relations. The first one, it's the perimeter, and the perimeter for the rectangle is 2x, okay, plus 2y. Also we have what? We have a, which is equal to x times y. Since they said the maximum area, so we need to find the maximum for a, which means I will use this relation for substituting. So in here you can choose y or x for substituting. So whatever, in here I can say that p minus 2x is equal to 2y. Okay, then divide by 2, divide by 2. This is going to be equal to y, it will be equal to p over 2 minus 2x over 2, which is equal to x. Okay, so this is my substitution. So now I will say area is equal to x multiplied by p over 2 minus x. Okay, then this is equal to p over 2 x minus x squared. I will deal with p over 2 as I mentioned at the beginning, it will be constant. Okay, so now a prime, this is equal to, the derivative of this is p over 2 minus the derivative of this part is equal to 2x. Now let's make this equal to 0. So just for finding the value of x, now p over 2, it will be equal to 2x. Now after that, divide by 2, divide by 2, or multiply by 1 over 2, both sides. Okay, so that will give me x equal to p over 4. We need to find the maximum or maximize the area. So in here the number line, okay, so over here I have p over 2. Okay, so this is p over 2. For sure I cannot take any value less than 0 for x. Okay, so this is going to be the maximum value, because if this is p over 4, sorry, this is not p over 2, this is p over 4. So this is 4. Now, how can I know that? How can I know that it will be maximum? Let's substitute any value. So for example, value less than b over 4 and greater than 0. Let's take for example in here. So just I want to make sure that the solution is correct. So we moved the 2x to this part. So after that we said divide by 2, yes, multiply, yes. Okay, so let's say in here, let's substitute p over 3 for example. Okay, so which is between, it will be p over 3, it will be greater than p over 4. So let's take p over 5. P over 5, it will be less than P over 4 and greater than 0, because in here once you increase the denominator, okay, the whole ratio it will be less. So if we said, for example, if I have p over 4, p over 5 is less than p over 4, p over 6 is less than p over 5, p over 7 is less and less, okay, etc. So let's substitute p over 5 in the derivative. So p over 2 minus 2 multiplied by p over 5. Now in here, to make the denominators the same, I'll multiply this by 5 and I'll multiply this by 5. I'll multiply this by 2 and this by 2. So that will be equal to 5p over 10 over here, okay, minus 4p over 10, which is equal to p over 10. So it's positive. So this value is positive. Now, if you try a value greater than, let's take p, it will be greater than p over 4. So, in here, let's substitute that in the derivative. So, p over 2 minus 2p, this is going to be equal to a negative value. So, in here, this is negative, which means in here, at x max at x equal to p over 4, let's find y. Y by substituting in p over 2 minus p over 4. So this is equal to p over 4. Which means if we have y is equal to p over 4 and x is equal to p over 4, which means they are equal, which means you have square. You have square over here. Okay. That's it. So let's see the same thing for the next part, which is in here, show that the rectangle of minimum parameter, now the opposite. So we need to minimize the parameter. So this is the parameter. So in here again we have rectangle. Okay. So we have rectangle over here. Okay. So this is x, y, and y. Okay, so the parameter again is equal to 2x plus y, 2y. We need to minimize that. And for a given area, which means the area is constant, x multiplied by y. So in here you can say y is equal to, in here, a over x. This is my substitution relation. So in here, I'll go back. I need to find the minimum of the parameter. So p is equal to 2x plus 2a divided by x. Okay, now directly, let's go ahead and start by finding the derivative. This is going to be equal to 2. Okay, then in here, plus, now the derivative for that is minus the constant, since this is a constant, so minus 2a multiplied by the derivative of the denominator, which is 1, over the denominator square. So now all we have to do is just making this equal to 0. Okay. Okay, so let's go ahead now. Before going to find the zeros, before finding the zeros, so I'll just try to find the domain of the original function. Now in here, this is the original. Okay, now the domain for this is r minus 0, which is the 0 of the denominator over here. So all we have to do is just finding the zeros. So in here, 2 is equal to positive 2a over x square after moving this to this part. So now multiplying. So this is going to be equal to x square equal to 2a. Then eliminated. That means in here x, it will be equal to square root, positive negative square root of a. Now in here, for positive square root of a, I will accept that. For negative square root of a, I will reject that because x logically cannot be a negative value. It's a length. So in here, all we have to do is just testing the value. So in here, we said from 0 to infinity. I have over here, I have square root of a. Okay, so all we have to do now is just testing the value. So less than square root of a, I will take, of course it will be minimum, but I will tell you how can I make sure that it's minimum substitution. So in here, I said the value less than square root of a, so I will take for that square root of a over 2, for example. So it will be 2 plus minus 2a divided by square root of a divided by 2 square. So this is going to be equal to 2 plus, okay, so this is going to be a, okay, because the 2 it will be eliminated with square root, okay, which is a square with square root eliminated, and square of 2 it will be 4. So flip the 4, this is going to be equal to minus 8a divided by in here a. So a with a eliminated, so 2 minus 8, which is going to be negative. So this is negative value. Now for value greater than square root of a, I will take 2 square root of a. Okay, so let's substitute that. So 2 plus minus 2a divided by 2 square root of a square. I'm substituting in the derivative. That's it. Okay, now let's say we have 2 minus 2a divided by 2 square, which is 4, and then here we have a. Now a with a eliminated, 2 over 4, which is 1 over 2, so 2 minus 1 over 2, which is going to be in here 3 point, sorry, this is 1.5, yes, that's it, which is a positive value. Okay, so this is a positive value, so that's it, which means in here the maximum. So in here, or we have positive, so which means in here minimum at x equal to square root of a. So let's find y, which is equal to, in here y is equal to a over x. So a over x, which is equal to square root of a. That's it. The end to a to the power 1 divided by, so in here this is a dot a to the power minus 1 over 2 after raising the square root to the upper side. So this is going to be equal to a to the power 1 over 2, which is square root of a. Now since y is equal to square root of a and x is equal to square root of a, that means we have a square over here as well. Okay, that's it. This is the end of this part. So next inshallah we will talk about part number 24. So see you then.